Hello, students. Let's say we want to count something using lists. So let's think about this. Suppose I want to, I don't know. Let's say I don't know how many numbers from um, 0 to 99 are divisible by 7. Okay, so how many numbers? How many numbers from 0 to 99 are divisible by 7? It's a good question. Let's see. What's one way I could do this? Well, one thing I could do is I could um, make a list of all I for I in the range from 0 to 99. So that would be 100 if I mod 7 equals 0. And then I could ask for the size of that list next. So I could just stick this right in there. And there are 15 numbers from 0 to 99 that are divisible by 7. Now, of course, if I take 99 integer divide 7, that's going to give me 14 numbers. And there's a reason for that. 99 divided by 7 means that you can take 7 14 times and have a remainder. And you can check the remainder. And have a remainder of 1. But this doesn't account for the fact that 0 is also divisible by every number. 0 doesn't divide any number, but it's divisible by anything. So since we chose to include 0 here, we actually get 15 instead of 14. Now, we don't need to know that. Python handles that for us. Python knows that 7 divides 0, but 0 does not divide 7. As a matter of fact, if you checked, let's say you wanted to divide 7 by 0, you will get a very clear message from Python, very clear name, 0 division error. So, and it says that either division or modulo, so you could be using either operation. Remember, the modulo gives you the remainder. So if I were to do 7 mod 0, I would get the same error. But we're getting off track here. What I want to know is I wanted to know how many numbers were divisible by 7 from 0 to 99. So one thing that I could do, a different way I could do this, is instead of taking the length, like instead of listing all the numbers, what I could do is I could make a list of all ones. And now I've made a list that's going to be all ones, but it only adds a 1 when this thing happens. So it only adds a 1 when our number is divisible by 7. So we're going to get a list of ones, and the number of ones is going to be the answer. It's going to be the number of numbers which are divisible by 7, and I get that 15 again as well. Okay, so this is another way that we can do things. Two different ways in order to get a length. With lists, you can't always do this with sets because repetition and things like that screws that up, right? Sets will change sizes based on whether or not numbers are repeated. Here, no numbers are repeated, so we would have gotten a set of the right size if we asked for the numbers. So length would work with sets. But what if I tried this trick with sets? Let's say I did this. 1. What happened? Well, what this did is it gave me a set and it tossed in a 1 every single time one of our numbers was divisible by 7, but it's a set, so all I had is ones, and it got rid of all the extra ones, and it says, hey, your size is 1. So you can't do this sum trick with sets. It's a trick that you can do with lists, and it's a trick that we can do with generator comprehensions, which we're actually going to talk about next. But let's do one more example where we compute a sum in more than one way. Let's try to see, let's take the function, I don't know, x squared plus 1. And let's try to see when that ends in 0. When does x squared plus 1 end in a 0. And of course, I have to, consider some range of numbers. I don't want Python to run for all of eternity and just keep checking numbers as we go to infinity. So I don't know. Let's say we go from 0 to 99 again. We'll do range 100. So let's check this out. We could check this in two different ways. Well, more than two different ways. So let's make a list comprehension where we take x squared plus 1 for x in range 100. So this is a horrible way is to check by hand, right? We don't want to do that. So let's say, okay, I want to know how often this ends in 0. Let's say this, I only want it if it ends in 0. So that means if we take this mod 10, we get 0. And I definitely want parentheses here because I want it to take that whole x squared plus 1 and give me the last digit. I don't want it to give me the last digit of 1. That would be very bad. So I need parentheses there. So what is this giving me? It's actually just picking out the numbers that end in 0 that are of the form x squared plus 1. Okay, but there's many different ways that I can adjust this. First of all, this is telling me, I had asked for how often this happens, right? Or no, I said when. I said, when does it end in 0? Okay, it doesn't tell me which x has it so that it ends in 0. So let me see, what are the x's that give me an x squared plus 1 that ends in 0? And I can ask here, okay, this is letting me know what the x's are. And as I see, I'm seeing I'm getting 3s and 7s, right? So it looks like that as long as my number ends in 3 or 7, I'm good. It looks like this pattern may continue onward. And in fact, it does. It's not a proof that it goes on forever, but I at least know that in this range, I have a proof. A computer proof, but a proof nonetheless that it happens for all the numbers that end in 3 or 7. I can see that from the data because I have every number that ends in a 3 or 7 there. And those are the only numbers that work there. And of course, there are other things that I can do. I could play with writing this in different ways. But let's say let's say I just wanted to know the number of numbers. Well, one thing that I can do is that. How often does it happen? It happens for 20 numbers. Okay. Another way I could have dealt with this is I could have said, hey, give me the sum, add 1 each time this thing happens, and I also get 20. So that's something else I could do. But do we really need to take the sum of a list? That's something we should look into next.